Welcome to the Next in Climate Change, the Ethel and David Jackson Next in Science program. I'm Immaculata De Vivo, one of the co-directors for science programming here at the Harvard Radcliffe Institute. And before I begin, I'd like to make an apology for myself for any of the missteps. This is the first for me of any kind of live programming for a long time, at least since 2019. Teaching doesn't count. I did that in the fall. But I am especially honored to be here today to have one of our very first live programming be on climate change. Climate change affects all of us, every activity, all human activity, big and small. There is a lot of talent locally as well as globally, so it's our job to harness this talent to help solve the problems, big and small, the scientific, social, economic, and health. And so it's especially rewarding to host Next in Science. This series at Radcliffe provides an opportunity for early career scientists. These are the creme of la creme, the rising stars, and they will present cutting-edge research, not just to themselves, but to fellow scientists, as well as non-specialists. And we are very grateful to our donors and friends, Ethel and David Jackson, whose support has made this event possible. The Jackson's ties to the Institute are long and deep, and we're thankful for their friendship, generosity, and support. Briefly, when we were designing this program, we wanted to use what I call a Radcliffe approach, that is to fill the panel with a diverse, multidisciplinary group of scientists. And in that, we did, because today the program will focus on 5 critical areas. 1, extreme weather and its impact on communities, infrastructure, and the environment. 2, economics, the effects of climate change, as well as the opportunities. The consequences of climate change on global health, ranging from cancer to mental health, and the impacts on vulnerable populations. And of course, I like to say we like to end on an optimistic note, mitigation and remediation. And so Ido and I had, again, a first time, had dinner with our speakers last night, and I believe it was Ji-Sung who asked me and Ido at the dinner, oh, how did you guys come upon this? And I immediately blurted out, well, it's a call to arms to defend the planet. We need to continue to take action. And so with that, I'd like to start the program and briefly give you an overview of the format for the day, or for the afternoon. So our terrific lineup of speakers, again, representing a range of areas of multidimensional impacts of climate change, they will present individually. And at the very end, we will hold a group Q&A. And that will be led by my good friend and colleague, Professor Ido Berger, who's also co-director here with me at Radcliffe. So with that, I'd like to start things off with the first segment of the program today. We will hear from Kimberley R, a scientist from the NASA Jet Propulsion Lab and research assistant professor at the Climate Change Institute, University of Maine. The title of her talk is Extreme Weather Under Climate Change, Causes and Consequences. Dr. Miner needs to depart a little early today, so in this particular segment, I will hold the Q&A, and I will take the questions again through the Slido. Following Professor Miner, we will welcome Ji-Sung Park, Assistant Professor of Public Policy at Luskin School of Public Affairs at UCLA. His talk is titled, How Heat Hurts, the Hidden Costs of a Warmer World. Professor Park will take questions with the other speakers at the end with Ido. Again, any additional information you'd like on these illustrious speakers, please go to our website, and there's more information there. And now, it gives me great pleasure to invite Dr. Kimberley R from NASA Propulsion Lab and the University of Maine to the podium.
Hi, everyone. Thank you so much for having me today. It's a delight to be here in person with you. Just to to echo what Max said, I also have not given a speech in public for almost 3 years, so hopefully you'll be able to bear with me if I also have a couple little missteps or frantic moments. But today I'll be talking about extreme weather under climate change, the causes, mostly, and some of the consequences. This is a very physics-heavy topic, so for the talk today we'll be going over very, very high-level perspectives. But if anyone has any questions and would like to contact me directly, I do have my contact information at the end of the talk. So, way back when I was just a sassy little girl sitting in my little bathtub, Dr. James Hansen was already briefing Congress. This was in the 80s, I won't give you exactly my age. He was already briefing Congress on the importance of understanding and mitigating climate change. Now that I am grown, I am carrying the same message that he shared many, many years ago. And the next generation, Generation Z, I think is what we're calling them, are having to pick up the exact same torch. But things have changed a little bit since that time. Over my lifetime, there's been a 21% increase in carbon on the planet. Now, don't look too carefully into what year I was born, but it's been not that long, especially in the geologic timescale, that we've seen almost a 30% increase in the carbon output into the environment. Now, when we're talking about carbon today, a good way to think about it is as energy. Just as like a source of heat, it would be a source of energy into the planet, so we're disrupting the energy system of the whole globe when we add additional carbon. Now, I know that it's been a rough few years for everyone, and I don't want to share too much disaster with you as we have a lot going on in our lives, but just as a gentle reminder of what we're talking about. This is a picture from the Amazon of recent burn events, significant impacts from hurricanes and tornadoes across the world, and especially across the United States in recent times. The boreal forests are burning at a quantity that we have never experienced in human history. And as you know, we're losing a lot of glaciers and permafrost at an incredibly rapid speed. Now, these are some of the extreme events that we'll be talking about today, but just let's take a quick step back and go over the energy cycle. This is one of my favorite images out of NOAA and NASA. It's almost a Picasso-esque understanding of the northeastern seaboard and the ocean currents as they travel up way from the Gulf all the way up north. You can see that the color changes as the heat changes. And just like in the ocean and the atmosphere reflects that the heat and cold in different parts of the planet, the high and low pressure in different parts of the planet, is the reason that we have overturning circulation in both the atmosphere and in the ocean. So it's this difference in heat and pressure that allows us to have normalized patterns in the atmosphere and the ocean that's resulted in a rather stable climate system for most of human history. Now, the northern parts and southern parts of the planet, the poles, are much, much colder, as we know, than the mid-latitudes, but they're also warming at a much more rapid speed. They're warming at about 8 times the speed of the rest of the planet. So from this graphic from NOAA, what that functionally means is that while the jet stream and the prevailing winds have been more or less stable because of this temperature differential over human history, we have disturbances that are emergent because of the warmth that is growing in the north and south poles and that is starting to spread and make the jet stream a little bit more wibbly-wobbly, if you will. In this graphic from AccuWeather, you can see that as the jet stream changes over time, we have a little bit of warm and cold pulses, maybe where we aren't used to them. These are some of the dynamics that we start terming extreme weather. Specifically, as the jet stream gets into a more negative oscillation or sets up into a dynamic that is different than in previous times, we have the opportunity to have warm and cold blocking in the atmosphere, which you'll see indicated by the blue and red circles. It's not always in those places, but basically what it means is that we're having weather in places that we're not used to having weather. And that is in part the reason that we are having some of the drought in the West Coast, the cold snap that happened in Texas in 2021, and also a lot of the melting that's happening in the Greenland ice sheet. So as the weather patterns that have stabilized over time and that have been stable for most of human history start to decay, we start to see more and more extreme events, extreme weather events. And these are really almost expected, although they're not necessarily where we would think or how we would think. We know that a destabilization of the climate system, both in the ocean and in the atmosphere, will lead to these abnormal events over time. This is a graphic from Swiss Reinsurance. Both Swiss and Munich Reinsurance do an excellent job tracking extreme weather events and characterizing them in terms of cost. You can see the hurricanes Irma and Katrina, Rita, Wilma, and Maria all standing out as significant weather events that have caused great cost. But if you look back into the 80s, back where we were talking about James Henson and Little Snappy Me, you can see a pretty significant increase in cost over time, almost a four-fold increase in cost over my lifetime due to extreme weather events or weather-related events. So I'm almost towards the end of my presentation, and I've really blown through this, so I hope you guys are all thinking of excellent questions since I've bought us a little bit of time on the Q&A segment. So paleoclimate does give us an index. As I'm sure you're all familiar, we're able to get an understanding of the geologic history of the planet because of a bunch of different assets that we have in the form of tree rings, in the form of sediment cores, and in the form of ice cores. They give us an understanding of what the Earth has looked like over time. If you see this little red line, this is us in the Holocene. So not only the human population, but everything that has co-evolved with us. The palm trees, the pine trees, whales, the songbirds. All of us are used to a regular, stable climate, a much more stable climate than you can see we had in the Pleistocene or even in the Pliocene. So when folks say, you know, the planet survived, it's just humans that we're talking about, you know, just a gentle reminder, it's really not just humans we're talking about. Everything that we have co-evolved with on the planet is in jeopardy when we're talking about climate change, more energy into the system, and any kind of subsequent extreme events. If you can see 2050 on the far, let's see, left-hand side, right-hand side for you guys, this is often referred to as the hockey stick graph. You can see that the carbon rate of carbon increase is significant, especially when compared to the rest of human history and the time since the last glaciation. As another reminder, you know, the Earth has gone through a lot of periods. There's even one called Snowball Earth that we think happened where the whole surface of the planet was covered in ice and snow. But these are not times that we would want to live in. We wouldn't want to live in the mid-Pliocene warm period. The last glacial maximum was also not a very friendly time. So even though there have been extremes on the planet, both in terms of cold and warm, a stable ecosystem that we have grown used to in human history is really what's necessary for this ecosystem and the co-development of life that we experience at this point. So what's next? I think my colleagues are going to do an amazing job of addressing this. I'm also really particularly interested in their insights because they're outside of my field. I'm working on a book right now with Schuster & Schuster looking at planning for climate change for my generation and younger. I'm an elder millennial, so there's folks my age and younger who are going to have to deal with this for their entire lives. But I would really encourage everyone to think about climate change in terms of your local environment, your community, your nation, and even your own families. As we start to approach this subject and deal with the reality of what's coming and what is going to happen, even if we are able to do some remediation efforts, we will suffer some consequences of climate change, as we already are. I would really encourage everyone to think about how it impacts you personally and how you can be a resource and an asset to your community, to your family, and to the world. Especially now that I'm talking to this amazing audience in this room. You have an incredible set of resources and skills that really could do a lot of good in this struggle as we move towards an uncertain future together. Because a lot of what I say in these talks is often doom and gloom, I like to always end with a nod towards one of my personal heroes, Carl Sagan. This is from his A Blue Dot speech. Our posturing, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from anywhere else to save us, but from ourselves. With that, I would love to take all the questions I've made extra time for, and I encourage you to reach out if you have any questions in addition or any specific physics questions. Happy to chat more about that.
Thank you. Thank you. So in compliance with COVID rules, I will keep my mask on, and Kimberly, if I may call you that, you can take yours off. And yes, we have a lot of questions coming in, and I will do my best to talk into the mic. That was great. And you know, gloom and doom, I think the jury's still out on that. But let me ask you some of the questions. What is the Paleoclimate Index?
I don't know. What is the Paleoclimate Index?
I'm only reading as they come in.
Well, we do have an understanding of paleoclimate, like I said, through a number of different sources. I haven't heard it referred to as a Paleoclimate Index, but just generally more recently, we have an understanding through ice core records from the Greenland ice sheet from GISP and GISP-2. We have tree ring records, and then we also have records from a variety of rocks and sediment over time. And that gives us an index, an understanding of what the atmosphere was like over time, geologic time, so really, really, really long ago.
Thank you. I'll take your word for it. Next question, does Professor Miner have any specific suggestions for remediation or mitigation that we in the audience can undertake?
Sure. I have things that I personally think are interesting and would suggest. I am a big fan myself, personally, of rewilding, so letting ecosystems go back to a more natural state, and sometimes that includes planting trees, planting natives, maybe that includes not mowing one's grass as often. Any kind of interaction with the earth that people can partake in, I think, is always helpful. So even if you live in an apartment, planting, a little box outside your window. We recently just installed a bunch of bird feeders and have been watching the incredibly dramatic dynamics of our local birds. Any reminder that we are part of this Earth system is a good reminder of how important it is for us to be engaged with and take care of the planet around us.
Okay. Well, the questions keep coming. About the sharp rise in cost due to extreme events, is there an effort to take growth in population and infrastructure into account, adding to the cost?
So I'm not 100% clear on how Swiss Re and Munich Re do their measurements. I believe that these are just actual insurance costs, so what is being paid out by insurers due to different consequences, both on private and on public property. So the reinsurance insure the insurers, right? So they would be getting the information from a variety of different sources and getting the totals of what they're spending and what global organizations are spending to deal with different impacts and consequences of risks.
Okay, here's an interesting question. Do you think we're in the Anthropocene era, and what are the practical implications of it?
Oh, fun question. So the Anthropocene is what we're just generally referring to as a post-industrial era. So if you think about the way that we look at sediments over time, right? You go out and you hike and you can see a cross-section of rock. You can kind of see the way that the Earth sediments have stacked up over time, or the way that things have transformed over time. So the idea is that eventually, someday, whether it's humans in the future, or aliens, will be able to dig down and they'll see a little layer of, plastic and maybe some lipstick and maybe some synthetic fibers. And that will be the Anthropocene. That'll be an indication of humans' footprint that's left in a really long-term way. And I think it is a lovely concept. I'm not sure that it's been completely accepted yet by Geological Society, but it is a very interesting way to talk about our footprint on the planet.
It's a quite dramatic way, too. I think you will get people to pick up the arms, so to speak, if they see it that way, that they're going to leave behind plastic and lipstick.
And not even lipstick specifically, right? Anything that we're using that are accoutrements that won't be biodegrading.
Yes, okay, all right. Is there a concern that some of the Arctic melting is viewed as financially beneficial by some countries?
Great question. Okay, so I do a lot of Arctic work. This is kind of my focus, especially in my current role. I think that there is an opportunity for resource extraction, both in the form of metals, oil, gas, and then a variety of rare earth minerals. However, the costs, I think, will be significantly greater than the benefits. When you're talking about permafrost loss and degradation, you're talking about infrastructure loss, the inability to travel across the portals that we've developed in the Arctic, unknown consequences such as toxins or biologic impacts that are released from the permafrost. You also have lost a huge long-term storage source of water and stability for the entire planet's climate system. So yes, there will probably be resource extraction opportunities, but I think the cost is going to be much, much higher than the benefits that it could in the short term pose.
I would have to agree with that. Another question. Can you comment on environmental racism and how to factor change to meet the very significant problem?
So in my opinion, environmental racism is a symptom of a larger system of racism, and it is a symptom of established networks and established protocols that have embedded racism in our culture. So when we talk about environmental racism, we're talking about almost a neglect for certain people, certain groups of people that aren't being considered in the same way in industrial plans, in infrastructure plans, in mitigation. And it's a huge deal. It's a huge problem. And in climate change, we're often talking about nations that don't have such a high GDP not being able to advocate for themselves, and maybe their consequences and impacts from climate change not being taken as seriously as if it was happening in a nation with a higher GDP. So I think this is an incredibly important topic, and I do think a couple of my colleagues will be addressing it a little bit more in depth today. I'm not an expert in this way, but I do think that we need to spend a lot of energy discussing how to remediate and how to fix some of the embedded and inherent racism within our system.
Yes, Professor Casey will address that later on. Another question here, what are you most interested in researching next related to climate change? And what is the next big question or set of questions? Yeah, big questions.
So we're doing something really cool, actually. We're using some of the technology developed in the Mars rover, and we're going to use it to look at permafrost and see if we can get an understanding of the biosignatures in this really, really old permafrost. And maybe that'll help us understand if we can find biosignatures in the permafrost in Mars. So the cool thing that I've learned working at NASA is that we can think about Earth, as a planetary system, just as we think about all other planets in our solar system and in our extrasolar system. And it means that we can use the same methods for exploring sometimes on other planets that we use on Earth. And it just gives us another reason to preserve our ecosystem so that we can then voyage from here with more knowledge.
Sure, it makes sense to look at our own stuff too, right?
Yeah.
I agree. Okay, so question for you, Professor Miner. Carbon and methane emissions in the Arctic are not included in current climate models. In your opinion, when and how should these models be included?
So there are a lot of folks working right now to include them in the models. We've got a couple different problems with the permafrost. One is where and when the highest emissions of both methane and CO2 will be emitted. And then the other problem is how to increase the micro to the macro scaling in these models so that we get a really good perspective of all of the different scales upon which climate change is acting and incorporate them into the models as sources of emission. So there's a lot of teams working on it. The NSTAR team that I just published a paper with out of CU Boulder, they're doing an excellent job. And I'm, again, happy to chat more about this with whoever that comment was from. Would love to share any more insights that I have.
There's a bunch of questions, but I think this is going to have to be our last question. So thank you very much for your wonderful presentation. We have to mitigate global warming. I wonder, is there any positive consequence of global warming? It's the last question. Sorry.
Mac, you got me here. Come on.
I could have picked an easy one.
Oh, you should have. So I always like to say that people can nickname me Dr. Doom because it's a little bit of a light and fun thing to think about when you talk about all the terrible things that I usually study. My personal opinion is just no. Let's just go with no. I would rather live in a stable ecosystem where myself and the hummingbirds are both happy than think about the potential positive consequences of our terraforming efforts. So let's just go with no on that, Mac.
I'm going to agree with you on that, okay? I'm going to say no, nothing positive. Okay, well, thank you very much. Kimberly, if I may, Professor Miner. That was great.